Welcome to this web lecture about the use of speech and audio in interaction. Let us start with this overview from the Schneiderman book that discusses some opportunities when to use speech or audio. It discusses some technologies. We won't go into real details of how speech recognition and audio really works, but it's good to know what exists and what doesn't. And we will talk about the problems or obstacles in speech recognition when we talk to the computer, and in speech output when the computer talks back. Speech and audio are most often used when other, more visual techniques are inappropriate or simply cannot be used under the circumstances. This is obviously the case for visually impaired users, but also for people with good vision, there can be a problem when eyes or hands are busy. We have to use speech input when our hands are operating a device. We have to get speech output from the computer when we cannot look at a display because we have to concentrate on something else. Like, for instance, when we are driving, it's a good idea to focus our attention on the traffic. Sometimes mobility is required. If we are moving about, then we are not always ready to use a keyboard or to look at a screen that is positioned somewhere. And sometimes there are cramped situations where there simply is no space for a keyboard or for a large display. We have to get realistic expectations about speech recognition. Science fiction movies show us a reality that in fact doesn't exist. The interaction you can have with Commander Data in Star Trek is not technically feasible at this time. Speech interaction with a computer also makes use of our working memory more than using a display. If you have an audio menu, for instance, you have to remember the menu items that just passed, whereas in a graphical system, we can still see them on the display. Background noise can be a problem. If there is a lot of noise, we may have trouble understanding the computer, but with today's technology, it's even more challenging for the computer to understand what we are saying if there is a lot of noise, for instance, from the fans of our computer or from other people in the background that are also having a conversation. But even in good circumstances, with a single user, there is a lot of variation in the user's speech. When I have a cold, my voice sounds very different from what it sounds like today. And for handicapped users, right, speech is very important, and technology developments often concentrate, right, on the circumstances where speech is actually needed rather than on creating speech applications just because we can. Let us check out the state of the art in voice recognition by using my good friend, the Google phone. Okay, Google. Call Reed at work.
Say the name of the contact you want to call or say, cancel.
Reed.
Try repeating the contact name or say, cancel.
Reed.
The person you're trying to call may not be in your contacts. Touch to pick a contact.
What we've seen is that first the phone thought that I was trying to call Rita, even though I clearly separated the words. Then when I repeated the contact, I very clearly pronounced Reed. My secretary's name is Reed, R-I-E-T. Yet the phone was unable to match my pronunciation to the name in the phone book because it insisted that that name must be spelled R-E-I-T. So our modern voice recognition failed in this case. What we saw in this short video is an example of problems that exist with discrete word recognition. Generally, this bit of technology already works quite well. There is a limited vocabulary that you need to, for instance, call someone on the phone, and the variations between speakers can be handled quite well by today's technology. We were just unlucky in the example that we used. For applications with more vocabulary and more continuous speech as well, we need to use speaker-dependent training. The computer needs to learn exactly how a specific user pronounces the different words from the language, especially since many people from all over the world can use the English language, but it sounds very different. Words are pronounced differently. The computers need to be trained. Speaker-independent systems are nowadays becoming quite reliable. Siri and Google Voice Search, for the most part, they work well. Again, we were just unlucky. We can use a voice-controlled editor for giving commands instead of using the keyboard for it. And we could actually use also a combination of, for instance, giving commands to the editor, but still typing the text, or the other way around, right? Giving commands with a keyboard, but say the text out loud and have the computer recognize it. Voice-controlled tool selection is a form, right, of this second option where we can tell the computer what to do, but the actual actions, and in, for instance, a drawing program, we cannot tell the computer how to draw a certain curve. We still do that with our hands. Continuous speech recognition, it's been tried, it's not generally available, but it works reasonably well when a computer can be trained. The biggest problem is for the computer to recognize word boundaries. In normal speech, we blur the boundaries between words. We often paste words together in what we say, so the computer needs more than just a vocabulary from the language, but needs to also recognize combinations of words that are pronounced as one. There are many useful applications that are possible if we can only get this technology to work correctly. So the future, right, is bright for people researching this area. Currently, continuous speech recognition is used a lot for dictation. When you suffer from RSI, a doctor will tell you not to use a computer keyboard anymore, but to use dictation. With enough speaker-dependent training, that is indeed becoming possible. Other applications are speech store and forward, to receive, replay, and reply to messages. Most of this is very easy. We won't concentrate on it here because the computer doesn't need to understand all the language. It is just like audio recording and playback. In voice information systems, where we have a dialogue like in a menu system with the computer, we need to consider applications where that is really useful. For instance, when we call a doctor's office after hours and we engage in a small dialogue with a computer, right, to decide whether we need emergency help or whether we just need to call back the next morning. Tourist sites, government services can offer this information, a dialogue in airports or train stations. There can be voice prompts to which we need to answer, but we can't have complex, deep menus because we will get confused. It will take too long. We can't remember all the menu items that passed. Right? So it needs to all be very simple and short. We can also be frustrated because of the slow pace of the voice output. We call a number and we get the impression that they're trying to take as long as possible because the meter is running on the phone bill. Other applications are voicemail, handheld voice recorders that essentially only record the audio. Right? There can be audio books, again, where it is possible to use voice output that is generated by the computer, but an audio book can also just be read by a person, right? And we're just playing that back. Speech generation is suitable for communication when we can't access a display and when the messages are short and simple. It need not be referred to later in a dialogue. And it's very useful for messages that deal with events. Like in a train station, this train is going to be 5 minutes late. Very, very useful to use voice messages for that, possibly in addition to showing it on a display. Also for messages you need to react to quickly and immediately. Right? Voice can be used because if the message is just shown on a screen, it may not be drawing our attention. Speech generation can be useful when we cannot actually look at a screen. For instance, again, in a station, you are not always within visual reach of the screens, so when a delay is to be announced, it needs to also be communicated with speech. This is also a situation where the users are free to move around and still need to get the messages, and we can hear the messages wherever we are. It's also used in cases where users are subjected to high G-forces or are deprived of oxygen. It appears that we are better at still reacting to a sound than to messages that are displayed, right, when we are in such distress. Other audio use, other than just spoken sound, can be with sounds, music, for instance, to give us feedback, to confirm actions. When we are pressing keys on a virtual keyboard on our phone, we want to hear something that tells us we pressed the keys. It can also be used to offer warnings. We are quite good at reacting to a doorbell that rings. Right? It doesn't have to be a spoken message that says there is someone at the door. Right? It's useful for visually impaired users. And apart from just sounds, we can also use music. Music, in addition to other interaction, to bring us into a certain mood. In games and in movies, there is always some use of background music. Sometimes it becomes even foreground music. Even though in most of the scenes in a movie that represent a real life situations, in the real situation, there would be absolutely no music. Yet we find it normal that there is music in a movie that tries to depict a realistic situation. So there can be unique opportunities for users in interaction, also simulating musical instruments. There are applications where people try to do jamming on the web, for instance, which is often it's a bit of a letdown because the real-time interaction isn't fast enough due to latency. We are interested to see what you will actually achieve in your final projects with the existing technology to do something maybe not with speech, but maybe with some audio or sounds to give us a more pleasant experience when we're trying to use your projects. Thank you for participating.